It is kind of funny how we think about technology sometimes. It's like we have spent, well, the last few years obsessing over building this massive million horsepower engine, right?
Absolutely. The biggest
Yeah.
engine in human history, really.
Exactly. And we are all just standing around it, marveling at how fast it spins and, how much power it outputs. But then suddenly we look down and realize we haven't actually figured out if the local roads can support its weight.
Right. The asphalt is cracking.
Yeah, the asphalt is cracking, the bridges are groaning. And I mean, that engine is a marvel, sure. But none of it really matters if the ground beneath it is just giving way. Welcome to today's deep dive, by the way. We are so glad you were joining us.
It really is this massive structural blind spot we have. We
Yeah.
get so caught up in the abstract capabilities of a new technology that we sort of forget it has to exist in the physical world.
Which is exactly what we are digging into today. I mean, for a long time, the entire conversation around artificial intelligence has been completely about performance. Like, how smart is the model?
Right. Or how many GPUs can you string together in one room? Can it write better code? Can it generate a more realistic image?
Exactly. But today, the stack of reporting we have in front of us, it really forces us to change how we frame this entire industry. Our mission for this deep dive is to look at a profound structural shift.
Yes, because the reality is that the core competition in AI is fundamentally shifting right now.
We are moving from a world where the only thing that mattered was usable AI, which just means, does the tool actually work, to an era of what we really need to start calling placeable AI.
And that distinction, the jump from usability to placeability, is basically everything. As AI moves closer to becoming this heavy, load-bearing civilizational infrastructure, the deeper question is no longer just what it can do.
Right. It is about where it is allowed to be.
Precisely. Before it can even be used, where is it allowed to be placed? And when we say placeability, we define that as the capacity to secure and maintain the physical location, the resources, the institutions, and even the organizational boundaries you need to run these systems continuously.
But, I mean, anyone listening right now is probably thinking the exact same thing I thought when I first started looking into this. We have had massive data centers since, what, the 90s?
Oh yeah, decades.
The internet has always required servers and cooling and a ton of electricity. So why is this suddenly a brand new crisis? I mean, when I think of AI, I still instinctively just think of, like, an app on my phone.
Or a chat window on your laptop.
Yeah, it feels completely weightless to me.
And that is the great paradox of our digital age, really. AI appears abstract. It seems digital and entirely weightless. But in practice, it requires incredibly concrete, massive physical conditions to exist at all.
Which brings us to the grid.
Exactly. To understand why this is so different from the internet boom of the 90s or even the cloud computing boom of the 2010s, we have to look at the actual mechanics of the power grid. A traditional power grid is built to handle cyclical demand.
What we call peaks and valleys, right?
Right, it fluctuates. People wake up, they turn on their coffee makers, they turn on the lights, and demand spikes.
And then they go to sleep, stop streaming their shows, and the demand drops. So the grid sort of gets to breathe.
Exactly, it gets to breathe. Because power grids do not really have massive batteries to store all this energy.
Yeah.
The electricity being generated at the power plant has to perfectly match the electricity being consumed at that exact second.
Wow, at that exact second.
Yes, instantaneously. So utilities use what are called baseload plants, like nuclear or large hydro dams, to provide this steady hum of background power. And then they spin up peaker plants.
Which are usually natural gas.
Usually natural gas, yeah. And they spin those up just to handle the spikes during the day. But training a frontier AI model completely breaks that dynamic.
Because the AI does not sleep.
It does not sleep
No.
and it does not fluctuate. Training a massive AI model is this continuous, relentless draw of maximum power for months on end.
It's basically a flat line at the absolute peak of the meter.
Right. The density of the GPUs required means you are packing unprecedented power demands into a very small physical footprint.
And from the reporting, I mean, a single AI data center can pull more continuous power than a medium-sized city.
Easily. And it never gives the grid a chance to ramp down. Our public infrastructure simply was not designed to support a factory that runs at 100% capacity 24/7.
And the physical constraints aren't just about the electricity hitting the servers either.
Yeah.
There is some really fascinating reporting from the Financial Times we're looking at today that digs into the water usage.
The water aspect is huge.
It is wild. And the surprising part to me was that the bottleneck isn't just the water being pumped directly into the data center to cool the servers.
Right, the Financial Times reporting highlights a really critical piece of the puzzle here, which is the indirect water load.
Because we usually just think of data centers using water like a giant swamp cooler, right?
Exactly, just evaporating millions of gallons to keep the ambient temperature down in the server rooms. But you have to trace the electricity all the way back to its source.
Right, the actual power plant.
Yes. The power plants generating the electricity for the data center, especially thermal plants like coal, natural gas, or nuclear, they use massive amounts of water to create steam to turn their turbines.
And then even more water to cool that steam back down.
Precisely. So when you factor in that indirect load, the total water footprint of an AI model is just staggering.
You are draining the local reservoir at the data center itself, and you are simultaneously draining another water source 50 miles away at the power plant that's feeding the data center.
It is a massive double hit to the local hydrology.
And the timing of this couldn't be worse, right? Because the Financial Times also points out that this huge surge in AI energy demand is colliding directly with the expiration of clean energy subsidies in places like the U.S.
Which is a major financial problem for these companies. It means the open market cost of securing clean power contracts is just shooting up.
So if you are an AI company, you are suddenly looking at public grids that are straining, and in some places they are genuinely failing.
And becoming incredibly expensive to use. You realize very quickly that the public infrastructure simply cannot absorb your growth.
So what do they do? Because, I mean, it is not like these multi-trillion-dollar tech companies are just going to sit around waiting for some municipal utility board to spend a decade upgrading local transmission lines.
Oh, they definitely cannot afford to wait. The friction is way too high. So they are doing something pretty unprecedented. They are building their own dedicated infrastructure.
They are effectively creating private escape routes from the public grid.
Exactly. And this is where that concept of placeability gets really, really concrete.
Yeah, let's break that down for the listener. It is like, instead of acting like a tenant who just rents an apartment and plugs into the city's water and power, these AI systems are basically being forced to build their own sovereign, self-sustaining cities.
Just to ensure they don't get throttled by public limits, Reuters has been tracking this extensively, and the solutions these companies are pursuing are wild.
Yeah, the Reuters reports were fascinating. They are looking into small, modular nuclear reactors, designing these advanced closed-loop cooling systems.
And relying heavily on what they call behind-the-meter generation. Let's actually unpack how those mechanisms solve the placeability problem.
Yeah, please. Let's start with behind the meter, because that sounds like accounting jargon.
It kind of does.
Yeah.
But normally, a power plant generates electricity, pushes it out onto the public transmission lines, that is the meter, and then it travels to your facility.
But those public lines are totally congested right now.
Exactly. So behind the meter means an AI company builds a data center right next door to a power plant and just wires directly into it.
They bypass the public grid entirely.
Completely. They do not have to wait for the local utility to approve a new high-voltage line because they never even touch the public network.
Wow. It is like building a private high-speed rail line directly from your factory to your warehouse just because the public highway is locked in a permanent traffic jam.
That is a great way to put it. And to solve the water issue, they are investing heavily in closed-loop cooling systems.
Right, because the evaporative cooling uses too much local water.
Yes. So instead of gulping down city water, evaporating it to cool the servers, and constantly demanding more from the city, a closed-loop system acts more like a giant pressurized radiator.
So it just reuses the same water.
Exactly. It recirculates the exact same water over and over, removing the heat using refrigerants and massive fans. So they are not constantly draining the local municipal reservoir.
But wait, that has to create a new trade-off, right? If you are using giant mechanical chillers and huge fans to cool the water instead of just letting it evaporate naturally, doesn't that require vastly more electricity to run all those machines?
It does. It is a fundamental law of thermodynamics.
Yeah.
You are basically trading a water problem for an electricity problem.
Wow.
You reduce your reliance on the local aquifer, which makes the local government happy, but you dramatically increase your continuous power draw.
Which brings us right to the nuclear option. Literally. The reporting mentions this partnership between a company called Valar Atomics and NVIDIA.
Yes, that is a really key example.
They're specifically conceptualizing these water-saving data centers powered by next-generation nuclear technology.
Specifically, small modular reactors, or SMRs. See, the traditional nuclear power plant we are used to thinking about takes a decade or more to build. It requires a massive footprint, hyper-complex, custom-built construction.
It is a massive civil engineering project.
Right. But SMRs are designed to be manufactured in a factory, shipped on a truck, and then assembled on-site to provide dedicated, localized, carbon-free baseload power.
So wait, the tech industry is essentially having to reinvent civil engineering just to keep their software running? Like, why is the software industry suddenly in the business of pouring concrete and splitting atoms?
It really all comes down to a fundamental misalignment in speed. You can think of it as a time pressure gradient.
Okay, I have to ask you to explain that because time pressure gradient sounds like a concept from, like, a sci-fi novel. What does that actually mean for us here?
Fair enough. It simply means that two interdependent things are moving at vastly different speeds, and that creates immense friction. The software side, the AI development, is moving at an exponential light speed pace.
Right, you can push a software update overnight.
Exactly. But physical reality moves at a linear, painfully slow pace. Pouring concrete, securing water rights, getting zoning permits for high-voltage transmission lines, fighting through environmental reviews, that takes years, sometimes a decade.
So the software is just lapping the physical logistics 100 times over.
Yes, exactly. And the only way for the AI industry to relieve that pressure is to internalize the infrastructure. If they rely on the public timeline, their multi-billion-dollar AI model is suddenly at the mercy of, a local zoning board or a rolling blackout.
They basically have to own the whole stack, from the software code all the way down to the uranium in the reactor.
They do. But, the physical geography of placeable AI, the land, the water, the nuclear reactors, that is really only half the story.
Right, because the reporting we are looking at takes a really sharp turn here. Placeability isn't just about the physical limits of a power grid. It is also about organizational and geopolitical constraints.
Yes. What happens when AI moves indoors into a corporate environment?
This feels like a crucial transition in how we understand this whole topic.
It is. When we talk about AI becoming infrastructure, we also mean it becoming the internal load-bearing infrastructure of corporations and governments.
Right. Just like a data center needs to be safely placed in a physical environment, an AI tool needs to be safely placed inside an organizational environment.
And getting placed inside a massive corporation is not as simple as just downloading a new app from an app store.
Definitely not. There is a highly relevant real-world example from Reuters that illustrates this perfectly. Alibaba recently banned the internal workplace use of Anthropic's Claude code.
And to be clear, they didn't ban it because it wasn't good at its job. It is a highly capable tool.
Right, it is very usable. They banned it due to alleged backdoor risks. And remember, we are just looking at this impartially to understand the dynamic, not taking any sides on the politics of it.
Exactly. But this forces us to ask, what does it actually mean to place an AI coding agent inside a company? These systems are not just standalone utilities anymore.
Like a calculator.
Yeah.
Right, a calculator is a standalone utility. You punch in numbers, it gives you an answer, and the data doesn't go anywhere.
Right. But an AI coding agent is fundamentally different. To do its job effectively, it needs deep access. It has to read the company's proprietary source code.
It scans internal documents, it handles security credentials.
Yes, it becomes deeply embedded in the entire software supply chain.
Let me jump in here, though, because if I am a software developer listening to this and a new AI tool makes me twice as fast, I don't really care what it's called, it's highly usable, why are we distinguishing so sharply between usable and placeable in a corporate setting? Like, if it works perfectly, why would a company's leadership step in and ban it?
Because usability is solely a measure of output. Can this AI write a complex Python script without errors? If yes, that is usability.
Okay.
Placeability, on the other hand, is about trust. It is about legal boundaries and systemic risk. When an AI tool is placed inside an organization, it is so deeply integrated that it essentially rewrites the operating system of that company's workflow.
So it's not just a tool you pick up and put down. It is an observer.
Precisely. It observes everything. And that fundamentally changes the questions a chief security officer has to ask. The primary concern is no longer just how fast does it code.
Right. It becomes, what exactly does this AI observe while it's working?
Exactly. When it generates a summary of our architecture, does any of our proprietary data leave our secure environment to run through a server in another country?
If the model itself is ever compromised by a bad actor, could it subtly introduce vulnerabilities into our core infrastructure without us even noticing?
Yes. So using our earlier analogy, it's kind of like hiring a brilliant, world-class contractor who does the work of 10 people.
But they demand full access to all your company secrets, and you have absolutely no idea who they are talking to when they go home at night.
That is exactly the dynamic. And when you bring geopolitics into the mix, the friction becomes insurmountable. If a company operates in China, like Alibaba, And the AI tool is developed by an American company subject to U.S. regulations and national security laws.
That crosses a massive geopolitical boundary.
It does. We are observing the structure of this dynamically changing landscape. The tool might be perfectly usable and technically flawless, but politically and organizationally, it simply cannot be placed there. The systemic risk is just too high.
It is that exact same friction again. Just like the data centers clashing with the local power grids, here we have the AI clashing against corporate security and national borders.
And as the sources make explicitly clear, these invisible organizational borders are becoming the ultimate bottleneck.
Yeah.
If a company cannot trust the AI inside its own walled garden, its technical usability does not matter at all.
The boundary conditions of a corporation or a nation-state are just as real and sometimes much more rigid than the physical limits of a power grid.
Exactly. Because you can build a private nuclear reactor to solve your electricity problem.
But you cannot build a private reality to solve a regulatory or national security problem.
Well said. You simply can't.
So what does this all mean for the rest of us? Because everything we have talked about so far feels like it's happening at the billionaire level, you know? Multinational tech giants, sovereign nations, massive utility companies.
Right, it feels very high level.
Let's bring this down to earth for you, the listener, and look at how this concept of placeable AI impacts our everyday world. Because this structural shift is trickling all the way down to local city councils and county zoning boards, isn't it?
It absolutely is. And there is a really deep irony here that we have to acknowledge. The original utopian promise of AI was that it would be this invisible force that reduced friction in our lives.
Right. The pitch was always, the AI will handle the spreadsheets and the complex logistics, and we will all have more free time. It was supposed to automate bureaucracy and reduce the burden of human decision-making.
But the reality of placing AI, of building the massive data centers, securing the water rights, laying the high-voltage cables, it creates the exact opposite effect.
It is generating a massive, overwhelming influx of new decisions for local communities.
Exactly. Think about a quiet rural county that suddenly finds itself on the radar of a major tech company wanting to build a gigawatt data center.
That local government isn't experiencing fictionless automation.
Not at all. They are suddenly forced to make incredibly complex, high-stakes decisions about land use and zoning. They have to evaluate the impact on public services, the strain on local roads during years of construction.
And the ongoing intense demand on their local utilities. And from what I read in the reporting, they even have to deal with noise pollution.
Yes, noise pollution is a significant, tangible factor.
Which is wild to think about. A computer being too loud for a town.
Well, when you have an industrial facility running thousands of massive cooling fans 24 hours a day, it creates this constant low-frequency hum. It affects local wildlife, it affects property values, and it genuinely affects the quality of life for residents living miles away.
Which means local leaders are forced into a series of very difficult zero-sum games. If the grid is completely maxed out during a severe summer heat wave, who gets the electricity?
Right. Does the hospital get it? Do the residential neighborhoods get to keep their air conditioning on?
Or does the AI data center get priority because they have a massive ironclad power purchase agreement?
And the same goes for water. Who absorbs the water demand during a severe drought? Does the city ask its citizens to stop watering their lawns and taking long showers just so the AI model can finish its training run?
It is crazy. These are no longer technical engineering questions. They are deeply political, deeply human questions about resource allocation.
And it completely changes the dynamic of local accountability. Because data centers, once they are built, they don't actually employ that many people.
Right, you might have, what, a few dozen security guards and server technicians?
Exactly. So the local economic benefit, the job creation, is vastly outweighed by the resource drain. If a localized AI infrastructure fails, or if a city's water supply is compromised because of it, who is responsible for explaining that failure to the public?
Who audits the system? Who grants the exceptions?
This is where that time pressure gradient we discussed earlier really hits home for everyday people. The tech industry desperately wants to move at the exponential speed of software. But society, local governance, and democratic acceptance, they move at the speed of trust.
And right now, those two speeds are fundamentally incompatible.
They really are. And that is where the friction is generating the most heat on a local level.
It is just incredible to step back and look at the whole picture here. We started this deep dive talking about how the entire tech world is obsessed with capability, how smart the engine is, how fast the software runs.
But everything we have pulled from the reporting today shows that AI is no longer just a clever piece of code floating in the ether.
It has become heavy. It is load-bearing civilizational infrastructure.
Heavy, resource-hungry infrastructure.
It demands concrete, it demands uranium, it demands millions of gallons of water and immense swaths of land. We have seen how these companies are trying to build their own escape routes, right?
Mm.
Closed-loop cooling and private nuclear reactors just to bypass the failing public grids.
We have also seen how placeability is entirely rewriting the rules of corporate security, where highly capable tools are banned simply because they cross invisible geopolitical lines.
And finally, we have seen how this heavy infrastructure forces local communities to make impossible zero-sum decisions about their own vital resources.
If there is one analytical takeaway to draw from this entire structural shift, it is that the rules of the game have fundamentally changed. Moving forward, the next phase of AI competition may not be about who owns the smartest model at all.
It will be about who can secure and maintain the physical, regulatory, and organizational conditions that actually allow AI to be placed, operated, and accepted in the real world.
Exactly. Who can actually pave the road strong enough to carry that million-horsepower engine?
I want to leave you, the listener, with one final thought to mull over as you go about your day. We have spent all this time talking about the massive dedicated infrastructure this technology requires. The private grids, the water supplies, the capital to build small, modular nuclear reactors.
It is a staggering amount of physical reality.
Right. So if AI truly requires this much physical reality to function, what happens to the communities or even entire countries that simply do not have the natural resources or the financial capital to host it?
That is the big question.
As this technology becomes the backbone of the global economy, will the future map of the world be divided not by who has the best ideas or the most brilliant coders, but purely by who has the physical power and the deep water reserves to keep the AI plugged in?
It is a profound structural question.
Something to think about. Until next time.